AP Calculus BC, Unit 5, Day 2, Office Hours. These are the odd answers that would not have been in the back of the book, but then these are a couple of the odds that were, and these are maybe better versions of them that you should be trying to go for. Okay, so pause the video if you need to check those real quick. Otherwise, the other odds, 1 and 3, are in the back of the book. No problem. They're the way they are. 5 and 7, though, these are maybe other or better answers. So let's go over these. Problems 1 through 4 say find the values A and B that complete the partial fraction decomposition. So essentially just break apart the fractions, no calculus, all integration. Number 1, x minus 12 over x squared minus 4x equals a over x plus b over x minus 4. So we got to factor this, I guess. We got to factor that first, and then part is going to be over x, and part is going to be x minus 4. I would multiply through by the least common denominator, and you get x minus 12 equals a x minus 4 b times x. So I guess that maybe these were there for you. I'm just writing down what I wrote down out of the book. So I'd use the heaviside approach, cover-up method. Put a 0 in everywhere. And that'd be negative 12 equals negative 4a. A equals 3. And then we could replace everything with a 4 instead to get rid of the a. And you'd have negative 8 equals 4b. So b equals negative 2. And that's it. That's your answer. Number 2, 2x plus 16 over x squared plus x minus 6. So if we factor this, it's going to be x plus 3, x minus 2. So we're going to have a over x plus 3, which I think they already did for you, plus b over x minus 2. So we're going to multiply through by the least common denominator. We're going to get 2x plus 16 equals a x minus 2 plus b x plus 3. Cover-up method, we could get rid of a first or b first, doesn't matter. If I get rid of b, I would plug negative 3's in for all the x's. That'd be negative 6. That'd be 10 equals negative 5a. A equals negative 2. Otherwise, we could plug 2 in everywhere, and that would get rid of the a term and leave you with 20 equals 5b. B equals 4. So, number 3, 16 minus x over x squared plus 3x minus 10. So if you factor this, it would be x, and it would be plus 5 minus 2 would give you a positive 3 in the term middle. They put the x minus 2 under a, so we need to follow them. Plus b over x plus 5. Multiply through by the least common denominator. We just get the numerator here. And we get a x plus 5 plus b x minus 2. If we get rid of the 2 first, or the b first, put 2's in everywhere, we get 14 equals 7a. A equals 2. Otherwise, plug negative 5 in everywhere to get rid of the a's, and that would give you 21 equals negative 7b. B equals negative 3. 4, 3 over x squared minus 9. That'd be x plus 3, x minus 3. This is not a repeated root. So they had a over x minus 3 and b over x plus 3. When you do your own, it doesn't really matter. But since we're using theirs, multiply through by the least common denominator. And we could plug a 3 in everywhere. And we get 3 equals 6a. A equals 1/2. we can plug a -3 in everywhere. You can get 3 equals -6b. B equals -1/2. So that was just some practice with partial fractions, breaking them up. Number 5 says to evaluate the integral. So let's see, it's x minus 12 over x squared minus 4x dx. So we got to factor this GCF x minus 4. So I'm going to put a over x plus b over x minus 4. You could do it the other way, that's fine. Now we're still integrating here, but we're going to take a little quick break to find, to break it down. So multiply through by the least common denominator, get x minus 12 equals a, x minus 4 plus b times x. You can plug a 0 in everywhere. -12 equals -4a. A equals 3. We plug a 4 in everywhere for all the x's. And you get -8 equals 4b. B equals -2. Now this time we're going to actually continue the problem. So I'm going to put the 3 in front and just do dx over x minus 2 in front, dx over x minus 4. And so we're going to get 3 natural log of the absolute value of x minus 2 natural log of the absolute value of x minus 4 plus c. So yeah, sure, that's an answer. But I actually am requiring you guys to combine, use log rules. So you can bring the 3 in and the 2 in, and then combine these with division. Natural log of the absolute value of x cubed divided by x minus 4 squared. We could make this a little nicer. Natural log of x cubed. So this is all inside one natural log over x minus 4. We can get rid of the absolute values in the bottom and just do squared because it's going to ensure it's positive. So it's probably one of the better answers right there. I think that's what the book had. Now 6 was 2x plus 16 over x squared plus x minus 6 dx. So we got to factor this, x and x, plus 3 minus 2. So this is going to be a over x plus 3 plus b over x minus 2 dx. So we do a little multiply through by the least common denominator, 2x plus 16 equals a x minus 2 plus b x plus 3. Plug a -3 in everywhere. And that goes away. We get 10 equals -5a. A equals -2. Plug a 2 in everywhere. And we would get 20 equals 5b. B equals 4. So now we're going to rewrite this. I'm going to put the -2 out in front and do dx over x plus 3. And then plus 4 dx over x minus 2. So this is going to be -2 natural log of the absolute value of x plus 3 plus 4 natural log of the absolute value of x minus 2 plus c. So sure, this is an answer, but I want you to combine these with log rules. So we're going to bring these in. It's going to be natural log of x plus 3 to the -2 power times x minus 2 to the 4th. And then we could, I don't really want negative exponents. So it's going to be natural log of x minus 2 to the 4th over x plus 3 squared plus c. We could drop the absolute value since they're being raised to even power, so that's going to ensure they come out negative no matter what. Now 7, let's see how this works. So 7, we have the integral of 2x cubed over x squared minus 4 dx. Now we can't jump into partial fractions right now because the degree of the top is bigger or equal to the degree of the bottom. So we have to do long division first. We have to do long division. So that would be 2x cubed. You could plus 0x squared plus 0x plus 0. You can divide by x squared plus 0x minus 4. First terms, 2x cubed divided by x squared is 2x. Multiply 2x cubed plus 0x squared minus 8x. Subtract, get positive 8x. And now this is smaller degree than that, so we're done. This is the remainder. So this equals 2x plus 8x over x squared minus 4 dx. Now at this point, I think we would use U-substitution for this guy. U equals x squared minus 4, du equals 2x dx. We can get rid of the 2. So I would integrate this guy on its own. That one doesn't need U-substitution. Plus, we have an 8, and we have 1/2, and it's going to be du over u. So that's going to be x squared plus 4 natural log of the absolute value of u plus c, which is going to give you x squared plus 4 natural log of the absolute value of x squared minus 4. Need the absolute values, can't get rid of them this time, and that would be your answer. Now, if you really want, you could decide to do like partial fractions instead of U-substitution. It's way more work. So, I mean, we could say 8x over x squared minus 4. That would be x plus 2x minus 2. So that would be a over x plus 2 plus b over x minus 2. So you could do this instead. I'm recommending you don't. So if you multiply through by least common denominator, we get 8x equals a x minus 2 plus b x plus 2. We could plug a negative 2 in everywhere. Negative 16 equals negative 4a. A equals positive 4. Plug a 2 in everywhere. We get 16 equals 4b. B equals positive 4. So you do that instead of U-substitution. So this is one way. And the other way is to do partial fractions. So what you would get is you get, well, I mean, you still have the 2x dx, and then plus 4 dx over x plus 2, and then plus 4 dx over x minus 2. It's just an alternative way to do it. So then you get 2x squared over 2 plus 4 natural log of the absolute value of x plus 2 plus 4 natural log of the absolute value of x minus 2 plus c. So then we could say this is x squared. We could use log rules. Now, since they both have the same coefficient, we could just sort of factor that out. And then it'd be natural log of x plus 2, x minus 2 inside the same natural log. And then we get x squared plus 4 natural log of x squared minus 4 plus c. Still need the absolute values. And guess what? Same answer. That was a lot of work though. So I personally would just take it. Just use U-Substitution. So I mean, here's the key idea. You always want to assume it's easy before you assume it's hard. Because assuming it's easy is going to potentially make it way harder and possibly wrong. So that's it. Check fix your answers.